All right, here we go. So I'm going to share my screen. Okay, and I'm just going to make sure I can see what you guys are seeing. So I'm going to turn my screen. All right, so I'm going to kind of scroll through and just kind of refresh you on the stuff we had already talked about. So we talked about momentum and it being a measure of how difficult it is to stop something that's moving. So remember, the faster or the heavier it is, the harder it is to stop it. Okay, so we've already talked about all this stuff. Okay, and then we learned the equation for momentum was mass times velocity is equal to momentum. Okay, and then we also learned that the letters for those, remember, P was momentum, M was mass, and then V was velocity. Okay, so when we did our calculations, everything was based off of, like, remember at first we were doing, sorry. Okay, so remember when we had to match, like when we did the quiz and you had to figure out what went where. Remember, if you look at your units, that'll help you out because anytime you see a number and it ends in kg, it's a mass. Okay, and anytime you see a number and it ends in ms, it's a velocity, or m over s. And then these are the units for momentum. Okay, so this is all stuff we've done before. Here's the um, triangle and all the different equations, like if we were to rework it and solve for m or solve for v. All right, and then we talked about if something is going faster, if something's moving faster, it's harder to stop, or if something is heavier, it's harder to stop. Okay, so now we're going to talk a little bit more about that in terms of these are just calculations. We had already done these. Okay, scroll through those. Um, we're going to talk about that in terms of something called impulse today. So we're going to learn a new one. It's called impulse. This is just saying, so before we get into impulse, this is law of conservation of momentum. Okay, and what this means is, who remembers Newton's third law, the third law? Very nice. So Jordan said, for every action, there's an equal and opposite reaction. Okay. So a really good example of that is like if you've ever played pool or shot billiards before. I'm going to show you guys maybe one quick video. But basically, if we know momentum is how much stuff is moving and how fast it's moving, it's just saying if you have a couple of different things, momentum doesn't change unless the mass or velocity or both of them change. Okay. And even more importantly, okay, sorry, let me look at where we are in our notes. Okay. Let me just show you. Let's see. Give me 1 second. I'm going to pull the notes up. All right, so if you're looking at your notes, I'm just going to hop into someone's folder, okay? So if we're looking at our notes, we're on a page that says Law of Conservation of Momentum, and then it says momentum is how much stuff is moving. So this is actually in your notes, okay? So remember, let me do a new share and just show you the screen. Okay. All right, so just if I go, I'm gonna go into whose folders? Oops. All right, I'll go into Edwin's folder. All right, so here, if you're looking at your notes, we did these practice problems right here. So we're right here, okay. So law of conservation of momentum, how much stuff is moving and how fast stuff is moving, okay? How much stuff is moving and how fast stuff is moving. All right. And then we were talking about law of conservation of momentum. So you're right here on your notes. Okay. And I'm going to go back now so you can see where we were. Oh, except for I have to New share again. All right. So it says momentum of an object doesn't change unless, okay, unless its mass, velocity, or both change. Mass, velocity, or both changes. Okay, that's if you're following along in your notes. Okay, but momentum can be transferred. So remember when we talk about, like, so when you say transfer, it means you can give it away, right? Like I can get rid of it and give it to you. So like if I wanted to, if Lydia wanted to transfer money to me, which I would gladly accept, she would give away her money and give it to me and I would gladly take it, right? She's nodding her head like, no way, Jose, but yes, okay? So momentum can be transferred. So that's exactly what happens when we play pool, okay? If you've never played pool before, I'll kind of show you a quick video, but usually you take the stick, which is called a cue, and you hit one ball, but once you hit that one ball, that ball has, you can't just directly hit the ball that you want to go into the pocket. You have to hit one ball, and then that ball has to hit another ball and make it go into the pocket, okay? So that's how we transfer, okay? So if a group of objects exerts on forces only each other, their total momentum is conserved, okay? So basically, on your notes, it says, what does conserved mean? Anybody want to give me a word they would like to use for conserved? If I conserve my energy, you're saving it. Excellent, okay? It means saved. That's all conserved means, okay? So their total momentum is saved. You don't lose any of it, okay? All right, I'm gonna try to show you, let's do a snippet of this video, okay? A snippet, and I'm gonna have to do a new share. Let's see. All right, I'm gonna turn this up. If it will play, is it going to play? Or is it going to play today, maybe? Oh, good grief. There we go. Okay, got it. All right, just a snippet. Let's see. Why can't I make this?
Nice shot, Tommy.
Oh my gosh.
Oh,
So slow.
mine not so much. Seems like the momentum of my ball got lost, or did it? Pool is a game of real skill.
Whew, this is slow, guys. All right, give me 1 second. No thanks. So slow. I clicked this 5 minutes ago. All right, let's try again.
And it's also a way to look at one of the most powerful laws. We'll find out how in this segment of Physics in Motion, as we look at the law of the conservation of momentum. In this series, we'll talk about a few conservation laws, specifically for energy, momentum, charge, and mass. These fundamental quantities cannot be created or destroyed. They can only be changed from one form to another, or transferred from one object to another. So what do you think happens to the momentum of billiard balls when they strike another ball? If you figured that the momentum is conserved, you're right. The law of the conservation of momentum says that in a collision between objects in a closed and isolated system, the total momentum of the objects in the system before the collision is equal to the total momentum of the objects in the system after the collision. Just like the other laws of conservation, momentum is not created or destroyed. There's another law of physics that might sound familiar when we talk about collisions. Remember Newton's laws, which predict the motion of most objects? His third law of motion states that for every action, there's an equal and opposite reaction. This means that objects exert equal forces on one another when they interact. One of the consequences of Newton's third law is the law of conservation of momentum. We can see it in action when you hit a straight shot, like this, and it does this. You exert a force on the cue ball, which makes it gain momentum. When you strike the ball, that momentum is transferred to it. When the ball collides with the other ball and the first ball stops, all the momentum has been transferred from the first ball to the second ball. But what about in this case? This time, the cue ball hits the other ball at an angle, and both balls are moving. So was the momentum conserved? If you answered yes, you're right. Remember that momentum, like velocity and direction, is a vector quantity. When the first ball travels in this direction, it carries some of the momentum with it. The rest is transferred to the second ball, but not enough to reach the pocket. However, none of the momentum was lost, only transferred. In equation form, we see that the total momentum, P, before objects interact with one another, is equal to the total momentum of all the objects after they interact.
Okay, I know that is a little choppy for you guys at home because I have it on my computer over here. So I'm going to stop it here. Let's just go back to our slideshow here. And this is, so let me do a new share. All right, but I will put that link in if you want to look at it later. I'll put it on Schoology and I'll put it in the chat, okay? All right, so that is law of conservation of momentum. All right, quick question. What is the point of an airbag? So you don't die if you're in a car accident. Very nice. What does it actually do though?
They
Hurt you.
amount of force where it comes like you crash, it kind of helps you stop.
Very nice. And what were you gonna say, Bless? Was that you, Bless, that was saying something?
Oh no, ma'am. But you said the point of airbag though.
Yeah, the point of an airbag.
I mean, just keep you safe if you get in a car crash.
Yeah, keeps you safe if you get in a crash. Okay,
Or it
so
can, like, prevent,
go ahead.
or it can prevent like you pushing like the mass, I guess, like the
Mhm.
force of the crash, so it can like block it out, I guess.
Very nice. Okay, so that's similar to what Jordan said as well. Exactly. So think about it. If you are in a car accident, okay, which we hope will never happen, okay, an airbag is going to lessen, okay, or kind of like Bless was saying, cancel out the force. And that's what Jordan was saying too. All right, so that's the whole point of an airbag. So this is the new stuff, so make sure you're paying attention and taking notes. Okay, all right, so here is the new part. So this is in your notes. Make sure you are on the page that starts with impulse, okay? Impulse, definition, change in an object's momentum because of a force acting on it, okay? Because of a force acting on it, all right? All right, and I'm gonna give you the formula in just a second, but let's look at this little truck right here, okay? All right, this truck has momentum. Remember, momentum is M times V, okay? So it has momentum, all right? It's gonna go through this stack of hay or whatever it is, and when it does that, it lessens the force. So notice the F is little right here, okay? So, all right, and that's because it takes a longer time for it to go through, okay? Now, down here, the momentum of this truck, once it hits the wall, okay, it did not lessen the time at all, so the force is really big, okay, really big. All right, so I would much rather, so this is kind of like the airbag lessens the force because it increases the amount of time it takes for your body to stop, okay? So, and versus it abruptly stopping and hitting the steering wheel or your windshield, it kind of slows, you still kind of hit it, there's something in between you, but it slows it down a little bit. But you know, like, in all honesty, it's airbags are, a lot of people get injured by airbags too, but I'd much rather be injured by an airbag than by like my windshield or another car, right? Okay. All right, so here is what we have for impulse, okay? Here are variables. Luckily, they all make sense. Impulse is I, force is F, time is T, okay? So impulse is equal to force times time, okay? So this is new stuff, so you should be writing down these equations, okay? Because they are, you're about to take a quiz over them, okay? Okay. So force, remember we always measure force. We've measured it before and we always measured it in newtons, okay? And then time, we typically measure that in seconds. So if we're doing newtons times seconds, the unit for impulse is just a newton second. So you can say NS, or maybe you want to say N.S, okay? It's the same thing, right? All right. So luckily everything else makes sense. Time is T. Time starts with a T is T. Force is F. Impulse is I. All right. Give you a second to write that down, and then I'm going to change the screen just a second. All right, so let's go to the next slide. Let me clear my screen. All right, so this one talks about why doesn't egg crack. It's another video. I'll send you guys the video. Let's get to some practice problems, okay? All right, what happens during a car crash, okay? So when we have a car crash, it's the same thing. This car has a force, this car has a force, okay? And it causes both of them to stop, but the momentum is conserved. So let's talk about, let's get to some calculations here. All right, car A, rear ends, that means it runs into the back of, okay? So car A runs into the back of car B with a force of 10,000 newtons over a period of 0.5 seconds, excuse me, 0.5 seconds. What is the impulse felt by the car? So remember we were doing our plug and chug. Let me switch to my notes, okay, so that you guys can follow along. All right, these are everyone's notes, so let me go to my notes. All right, we are on impulse. Make sure you guys are seeing what I'm seeing. Where are my notes at? They're blank. Ah. Sorry, guys. There we go. There's... All right, impulse. Here we go. All right, so we were just a little bit. Just a little bit bigger. All right, so we said the formula was I is equal to, is it F times T? F times T, all right. And then this was I, F, T, Newton second, Newton second. All right, car A runs into the back of car B with a force of 10,000 newtons, okay, over a period of 0.5 seconds. And they want to know what is the impulse felt like RD, all right? We already know the formula is I is equal to F times T, okay? So we need to figure out what is I, what is F, what is T, all right? Which one of these are we looking for? I, F, or T?
We're looking for the fourth step, so
Looking for I, Jordan says we're looking for I, that's correct. So that means we must have F and T. And I know some of you guys are like, oh my gosh, it's so easy. But let's just do this one straight out and then you can kind of move at your own pace. Go ahead.
Alright, so since the 2000 is the force,
Very nice.
and then the time period from us, you gotta multiply, and you can get 5,000.
Very nice. All right. So Jordan went ahead and did everything for us. That was excellent. He said the force is 10,000 newtons. He's correct. And then he said the time is 0.5 seconds. So remember, that's the same thing as saying 0.5. Okay. And then he went over here and plugged everything in. So we didn't know I, so we just left it as I. And then we had is equal to 10,000. Okay, times that 0.5. All right. And then when he put that in his calculator, what did you get? Where did you get 5,000?
Yeah.
All right. If you put in his calculator, he got 5,000. Somebody tell me what the unit should be. What should I write behind the 5,000? Somebody online tell me. Hello, are you guys sleeping? You know unit? What's the unit? NS, very nice. The unit is NS. All right. Questions on that one? Good job, Dylan. All right, NS. All right. I'm going to scroll up. I'm going to have to clear my screen. Here. All right. And all right, let's see. Now, this next one is a little bit different. Let me show you how that looks, okay? All right, so we did this one already. That's the one we just did. We got 5,000 in this. Now, here's a slightly different formula, okay? It's a lot of stuff to fill in, so I'm just going to give you a second to fill in everything, okay, on your notes, okay? So this says impulse is change in momentum, okay? Impulse is change in momentum. Don't get freaked out by all that stuff. It's not difficult, I promise you, okay? So I'm gonna give you a second to fill all that in. All right, so again, these are essentially the same. I is F times T. P is M times V, so a change in P is M times VF minus VI. So for instance, if we were looking at just this equation right here, which looks kind of complicated, okay? It looks complicated, but it's really, really not. If I said, okay, you guys listen, you have to listen. Or actually I can write it. If I said 0 meters per second, there's only 2 places it could go up there. Where could it go? So I'm looking at this equation right here.
We're gonna go for the VR, right?
Yep, and where else could it go?
You can also go for final velocity, so.
Right. Depending on where I said, how I said it in a question, 0 meters per second has to be VI or VF, right? It has to be because meters per second always measures velocity, okay? What if I wrote this? Where would that have to go? From what? It has to go in mass because mass is always measured in kilograms, okay? If I wrote this, be careful, that's 2 letters, just one. Very nice, all right. You guys online, are you guys still there? You with us? I haven't heard anything from anyone.
Yeah.
Okay, so they said for this one, 5 newtons, okay? That one would have to go with F, okay? Because force is always measured in newtons, okay? And then if I said something like, how about 7, oops, that's supposed to be a 7. How about 7 seconds? Where would that have to go? For time, okay? Because time is always measured in seconds, okay? So it looks complicated, but as long as you, I cannot emphasize enough how much time it'll save you. If you know your units, okay? If you know your units, all you have to do is plug those numbers into the place, okay? Because I'm always going to give you the equation. So as long as you know your units, you'll be okay, all right? So now let's look at an actual practice problem, okay? So I'm going to clear my screen. Can I clear my screen yet?
Yeah.
Okay, no one objects, okay. All right, so if we were to look at a practice problem, okay, such as this one, okay? This is just, give me 1 second here. I'm going to try to switch back to my notes so you guys can do it. Actually, let's switch to. All right, so let's look at this. Now let me write the equation again for you, okay? And I want you to see if you can put the numbers in the right spot. So I'm going to space them out, okay? So the equation was, let me do it in black. It was, let me just make sure. Was it FT? Is that the beginning of the equation? FT, okay. F T equals M. All right. If you look at this equation, okay, I'm just going to go through and read this problem, okay? So I should have, okay, if you think about it, okay, we're always going to be looking for something, okay? So that means I should have, let's see, there's 1, 2, 3, 4, 5 variables. So that means of those 5, I should have numbers for 4 of them, and 1 should be missing, and that's the one I'm solving for, okay? So here's what I look at when I read this. Let's see, okay? I'm reading this, and I see a 1,200 gram car, okay? So I think this is gonna have to go somewhere. I'm not gonna say where it goes yet, you don't have to. A 1,200 gram car accelerates from rest to 27 meters per second, 27, I'm just gonna write it right here, meters per second in 12 seconds. I think that's something too. And then they said, calculate the force, that must be what they're looking for, of the car's engine, okay? Now, here's the problem. I only circled 3 things, and I said I should have 4. So what am I missing?
Wait, no.
So we got F, T, M, VF, and VI. Okay, so let's figure this out first. The first thing is, somebody tell me what we are looking for.
Oh, no, you have.
Ooh. Thank you. And Jessica also said, I forgot to circle this part that says from rest. Remember we talk about when stuff is at rest or when it stops? That actually has a number associated with it. If it's not moving, that is very nice, 0 meters per second. So now you have 0 meters per second, you've got 27 meters per second, you've got 1,200 kilograms, and you've got 12 seconds. See if you can put them all in the right spaces based off of this list right here, okay? See if you can put them in the right spaces. I'm gonna give you like 2 minutes, okay? See if you can put them in the right spaces. And then if you can do that, see if you can just plug them in. You don't have to solve for it yet, but see, like if you get T, put T in the equation, okay? Or write the equation with the numbers in them. instead of letters, okay? Let's take a second to do that. All right, can somebody tell me, so I think Jordan already said F is what we're looking for, okay? Because it said calculate the force, so that means we don't know it yet. So that's what we're looking for. Bless, can you give me any numbers that you want to give? You can give me T, M, V, F, or VI. And then Jessica, if you want to give me one, you can put it in the chat if you want. And then how about, let's see, who else? Who else we got? Aurelia, if you want to give me one. And how about Fizz Martin, if you want to give me one? Jessica, I guess you technically gave me one already, didn't you? Yep, you could just say. All right, Jessica said V final is 27 meters per second. She is correct. V final is 27 meters per second. All right. Ms. Marlin said M is 1,200 kilograms. She is correct. All right. Who else did I say? I said Blessing somebody else. Oh, Aurelia. Okay. So we still need time and we need VI. Yeah. Can someone-
The time is 12 seconds.
Okay, Jordan gave me time. He said it was 12 seconds. And oh, very nice, Jessica. Very nice. All right, Jordan said time is 12 seconds. All right, that leaves my VI. It must be 0, which technically Jessica gave us earlier as well too. Okay. So now we're just gonna write this equation again, but with the numbers in there. All right. So I still don't know what F is. I'm gonna put F. All right. And then I'm gonna plug in everything else I got. So I do know T. That's 12 seconds. I'm just gonna put in parentheses. If you remember, that means to multiply. So it's like saying F times 12. Okay. And then you guys told me M was 1,200. All right. And then that's going to get multiplied by, don't mess this up. You got to open parentheses because we're going to have to subtract that before we multiply it. VF is 27 minus VI is 0. All right. So before we multiply, we have to subtract. All right. So we still got, for this down here, it's going to be 1,200 times 27 minus 0. That's easy. That's just 27. Okay. Did I do that right so far? All right. On the other side, you still got F times 12. All right. So we need to multiply that 1,200 times 27. I do not have a calculator. Anybody got a number for that already? 1,200 times 27. Whew, that's a big number. All right, I got 32400. Is that what you guys got? Let's see. Yes? Okay, good. Thank you. All right. So on this other side, we still, so far, very nice. Adele says, so we still have this F times 12. So she said for us to get F by itself, we need to divide. She is correct, okay? So what we're gonna do is we're gonna divide this side by 12. All right, which means this cancels out. And then we're gonna also divide this side by 12. And that's how we're gonna get our F. So I got, see if you got this on your calculator. F is equal to 2700. Is that what you guys got? Very nice. I need a letter behind that or units. Okay. What did you say? N. Very nice. All right. So see, it looks like a really complicated equation, but it's not too bad, especially if you know your units. Okay, if you know your units, you're gonna be A-okay. Okay. All right, so I'm gonna give you a second to make sure you got all that down. And then Do you guys think we need to try one more, or do you want me to go ahead and open up the quizzes? Okay, I will open up the quizzes. All right, and then if you have a little bit of trouble, let me go ahead and make sure I give you a couple of, how about 3 attempts? Is that good? I think 3 attempts would be good, okay? And then what I'll do is I'm gonna open up these quizzes because some people are probably like, I got this. And then I'll do another one just in case. So let me open this up. Okay. So be very careful. I'm gonna open up 2 quizzes. One is for just momentum and one is just for impulse, okay?